This is the section of notes for Chapter 20, Section A, about rates of change. This is our introduction to calculus. The first thing we're going to talk about are rates of change. And I have an example for you here. If you notice, this is a cylinder, and if you added water at a constant rate to this cylinder, the rate at which the depth increased would be constant. So if we add water in the top, it'll fill at a constant rate, and we get this depth time graph where everything is a constant line. So there's a constant slope there. Secondly, if we look at the next shape down here, well, this shape is not a cylinder. This is more like a cone or like a solo cup. And as you fill this cup, the bottom is going to fill at a faster rate than the top is, because the bottom is narrower. So when we look at the curve to the right, the curve starts off steeply and then levels off as the cup gets wider. So the purpose, or one of the purposes of calculus, is actually to investigate the rates of change in curves. We know how to find the rate of change in a line because the equation of a line is y equals mx plus b, and we know that m represents the slope, and the slope is the rate of change. It's the change in y over the change in x, and that symbol is delta. That triangle is delta. It means change in, or difference in y's. When we look at the curve down here, however, this curve doesn't have one rate of change. It has several different rates of change. So we can't say that the curve has one particular slope value. So that's kind of what calculus helps us do. It helps us determine either the average rate of change for that curve or an instantaneous rate of change for that curve, or the rate of change at one particular point. So now turn to the first packet that I gave you. It's labeled Math Studies 2, Introduction to Calculus. And we're going to talk about slope and rate of change. Just so you remember, slope is rise over run, which is the same as the change in y over the change in x, which you can also write as delta y, delta x. So go ahead and pause the video here and solve these problems. Once you solved the problems, you should have gotten a slope of 1/4 for number 1, a slope of 3/7 for number 2. For number 3, you should have gotten an undefined slope, which, just as a reminder, that means you have a vertical line. And for number 4, you should have gotten 0, which, just as a reminder, means that you have a horizontal line. Alright, as we keep going, so a line has a constant slope or a constant rate of change. So a straight line has a constant slope or a constant gradient. This next part, though, is pretty important. So a curve does not have a constant slope or a constant rate of change. A curve does not have one rate of change, but we can talk about the steepness of a curve by finding the average slope of the curve between 2 points on the curve. So go ahead and turn to the next page, figure out the coordinates for A and B, and then find the slope, and then do the rest of the problems too. So go ahead and pause here to answer those questions. Alright, so for the first graph, you should have found the coordinates of A were -1 and -3, and the coordinates of B were 2 and 0, and when you calculate the slope between those 2 points, you got 1. So the average slope of the curve between A and B was equal to 1. For the second example, you should get -3 for y at point A, 0.75 for B, and when you find the slope, you get 1.5. So the average slope of the curve between A and B is equal to 1.5. For the next example, y was -8 at point A, and at point B, y is equal to 8. So the average slope of the curve between A and B is equal to 4. So the slope of that line is equal to 4. Turning the page, in the next example, you found in this case the slope between A and B is going to be 0 because this ends up being a horizontal line. So the average of A and B is a slope of 0. There's only actually one place on this curve that has a slope of 0, and that's at the vertex down here. But if you pick 2 points on the curve, as long as they're symmetrical, they'll always have a slope of 0. Then I asked you to find the slope between point A and the vertex. So that's going to be the slope of this line. And then I asked you to find it between point B and the vertex. That's going to be the slope of this line. Again, you notice that those two lines, those are symmetrical as well, or they are mirror images of each other. So you got mirror image slopes, a -2 and a +2. Okay, go ahead and turn the page. And on the previous page, there's that large parabola. What you're going to do at this point is find the y coordinates for each one of those 3 points. If you need to, you can actually just plug it into the function that's listed here to solve for y. After you've done that, find the slope of the secant lines. And as a reminder, a secant is a line that touches a curve in 2 places. It might touch in more, but mostly when you talk about secants, you're just talking about the segment that touches the slope at 2 places, or the curve at 2 places. If we go back to those previous problems, so this line that I drew here, this was a secant because it touched the graph at point B and at the vertex. All right. Okay, so once you find the y coordinates, then you'll use a ruler to draw the secant lines and then find the average rate of change of the function between each of those points. So after you've done that, pause here and then restart the video. You'll see the y coordinates are listed for you here. And then I took those y coordinates and I found the slope at each point. So let's go back to our picture. Alright, so what you should notice here is that for each of these curves, or each of these slopes, we start with a point like point B that's relatively far away from point A. And we move that point closer. So then we went to point C, and then we went to point D, and then we went to point E. As that second point moves closer and closer to A, the secant line turns into the tangent line. So let me be specific about a tangent line. A tangent line touches the graph at only one point. So a tangent line is only going to go through one point of the curve at a time. So as our point B, C, D, E get closer and closer and closer to A, the secant lines that we've had actually get closer and closer to being the tangent line. Alright? And when we have a tangent line, the slope of the tangent line becomes the average slope of the curve at that point A. Alright? So if we go back to the previous page, as the second point moves closer and closer to A, the secant line approaches the tangent line to the curve at A, and the average slope of the curve appears to approach a value of 1 at A. So now we can talk about instantaneous rate of change. Think for a moment about cruise control in your car. When you're driving on the highway, if you look at your speedometer and then look up, you know the speed for the instant that you looked at the speedometer. So if you set your cruise control, so if you look at it and it's 70 miles per hour, that means at that one particular instant you were going 70 miles an hour. If you set your cruise control for 70 miles an hour, then your average rate of speed is 70 miles an hour, but your instantaneous rate of speed will be the same. So think about it like the secant line and the tangent line. As the secant line gets closer and closer and closer to being the tangent line, the rates of change, or the slope, are the same. When you have cruise control on, your average rate of speed is the same as your instantaneous rate of speed. When you're talking about math curves, as the secant gets closer to being the tangent, then the average slope of the curve actually becomes the instantaneous slope of the curve, or the instantaneous rate of change. So in this case, again, our instantaneous rate of change is going to be equal to 1. Alright, the information in the box is really important, and it's what I just said. The slope of the function at any point on the graph of the function is equal to the slope of the tangent line drawn to the function at that point. So if I have a curve that looks like this, if I draw a tangent line that touches my graph just at that one point right there, the slope of that tangent line is equal to the instantaneous rate of change of the curve at that point. Alright, so that's section A. Go ahead and do the text exercises to practice before you move on. That's it.